like to welcome everybody to this SCS meet and greet for two of our new faculty. I'm Jessica Hodgins. I'm faculty in the computer science department and robotics. I've been at CMU now for about 20 years, which is kind of remarkable to think about. I work in computer animation, simulation of humans. I'm interested in trying to understand how people move and why they move in the ways that they do. So we're going to organize this by starting out with some short introductions about our two new faculty, and then we'll watch a video, a short video of their work, and then we'll move to Q&A with questions from the audience. So we have two new faculty here. First, Zac is coming to us from an assistant professor role at Stanford, where he was for a couple of years. Before that, he was a postdoc at Harvard, and he got his PhD and other degrees from Cornell. He started in September 2020, and he works in control and numerical and optimization. So his lab, he and his students are interested in developing algorithms that reason about a robotics physics, its environment, its actuators, with the goal of allowing it to move with agility and efficiency. And he works on a wide range of hardware platforms, including drones, legged robots, and probably most excitingly, spacecraft. And Jun-Yan is the other faculty member that we're introducing in today's session. He was born in Shanghai. He did his postdoc at MIT, his PhD at UC Berkeley, and his bachelor's at Tsinghua. He also started in September 2020. So both of them have been suffering through the pandemic and these odd circumstances as they've tried to ramp up as faculty. And we should applaud you both for that. It's not an easy time. Jun-Yan works at the intersection of computer graphics, computer vision, and machine learning, and his current research focuses on deep generative models for image and video synthesis and synthetic data generation for vision and robotics tasks. And he wants to help humans understand and to learn how to customize deep networks more easily. So with that, I'll turn it over to our host, and we'll watch the two pre-recorded videos of their research.
Hi, I'm Zac Manchester. I'm an assistant professor in the Robotics Institute, and I'm the PI of the Robotic Exploration Lab. And we work on, in my lab, something called motion planning and control. And I like to think of this as the science of moving things. It's sort of how we get robots and other systems to do what we want with algorithms and software. So to give you a little bit of an idea of why we work on this stuff and what it's all about, I'd like to start out with one of my favorite robots, the Mars Curiosity rover. Curiosity's been on Mars for about 8.5 years in one of the harshest environments imaginable. And in that time, it's gone about 23 kilometers. This sounds kind of impressive until you divide those two numbers and see that that works out to about 7.5 meters per day. Why is this number so low, right? The answer is that Curiosity is not very autonomous. In fact, it's not really autonomous at all. There's humans driving it back on Earth. And so everything Curiosity does has to be analyzed, planned, and then commands sent up from the ground by controllers. And this leads to really high latency. And what my lab tries to do is make systems like this able to control their own motions and go where they need to go without human intervention. This is some work from my lab from a few years ago, showing planning on a dog-like robot called Little Dog. And you can see we can get these things to climb stairs, and the bottom right shows limping when it's had a damaged leg. So this looks really nice, right? It looks very animal-like, but the problem is that this stuff right now, these few seconds of motion you're seeing here took more than 30 minutes to plan offline. So we're nowhere near being able to do this stuff online on the robot in real time like those mountain goats you saw. So what we've been working on in my lab for the last couple of years is trying to speed this up. So we've built new algorithms. We have a custom solver for this kind of stuff we call Altro. And we're right now about 1 to 2 orders of magnitude faster than kind of the standard off-the-shelf solvers that people use for this stuff on a bunch of benchmark problems. So this is great, but we're still an order of magnitude or more too slow for the dog robot or the mountain goat scenario that I showed you before. So we still have a lot of work to do. But this new solver technology has enabled a whole bunch of interesting applications in the meantime that I'll kind of tease a little bit. So we do a lot of work on space applications in my lab. And one area that's gotten really interesting recently is on-orbit servicing, so docking, proximity operations, trying to refuel satellites. So we do some work in that area. We also have a project with NASA to do trajectory planning and control for entry vehicles to land on Mars. And the challenge here is that you don't really know what's going on with the winds and you have a lot of uncertainty, but you still need to do a pinpoint landing and guarantee safety. So that's really challenging. We do some work in cooperative control. So in a multi-agent setting, we have multiple robots that need to collaborate and cooperate to achieve a common goal. We can build algorithms that let the robots talk to each other and coordinate their motions like this. We also similarly work on what's called game theoretic planning. So this is a multi-agent setting where you're not cooperating, where it could be adversarial. And it turns out this is directly applicable to autonomous driving, to things like highway merging, where you have to reason about what the other agents are doing, but you're not directly collaborating with them, right? We also do a lot of work on small satellites. So this is what's called an attitude control problem. So pointing a small satellite, getting it to slew around and point cameras at the ground, say, or antennas at a ground station. And we've actually built 3 of these little satellites. One of my grad students actually built these in his kitchen over the last couple of months because of COVID restrictions. And these are going to fly next week, fingers crossed, on a SpaceX launch to demonstrate some of this stuff on orbit. The last thing I want to throw out there is that on the hardware side, on the space side in particular, we actually do a lot of open source hardware development and outreach stuff on these small satellites. All the hardware for those satellites has been open sourced. The designs are publicly available, the code's publicly available. And we've had a lot of student groups at other universities actually build these things and use them in courses, and it gives you the ability to put together a satellite for a few $100s and puts it within reach for small student teams. So that's kind of a brief overview of what we're all about in my lab.
Hi, this is JunYan Zhu. I'm an assistant professor at School of Computer Science with Robotics Institute, as well as with Computer Science Department and Machine Learning Department. I'm working on computer vision, computer graphics, and machine learning. Today I will talk about some of our recent work on how to use AI for create content for both humans and machines. So humans have created various content throughout history, from the ancient cave art to Michelangelo sculptures, to the Impressionist painting, to more recently we have 3D computer graphics. This is one of my favorite movie, Life of Pi, which tells a story about a little boy with a giant Bengal tiger. But who is creating so much kind of exciting visual content? It turns out only a few chosen talents can do that, like the well-known painters and sculptors, as well as award-winning film directors. Why is that? Because content creation is very time-consuming and expensive. For example, in the movie, to create this video, professional visual artists have to specify everything just correct, from the skeleton to geometry, to texture, to very small details like tigers' furs, to make an image look realistic. It took hundreds of artists 12 months, $60 million to produce such a movie. Well, what about the rest of us who also have a story to tell, who may not have $60 million in hand? What can we do? So my long-term goal is to help everyone create visual content more easily. And my approach is to use machine learning and AI to first teach machines how to create realistic content and automatically. And human just does not have to create content by themselves. They just need to tell machines which kind of content they would like to have, and the machines can fill in all the details. Some of our recent work includes pix-to-pix, which is a method which can translate an image from one domain, like this kind of sketch, to a new domain, like an image domain. One example of this application is actually that the online link is called Edge-to-Cats, developed by our friend Chris. Here, a user can draw a cat and press the button. Here's another cat, and it's quite easy to use. You just draw something, you press the button process, and it can create a cat for you. Here are more creative cats, crazy cats created by our users. Honestly, I don't know how they do that. What is that input edge? Another system we have been working on is called Gauguin system. Here, the artist is demonstrating our system in front of 5,000 audience in SIGGRAPH, and the artist can specify which kind of objects they would like to draw, like either a mountain or water or maybe sand. And the machines learn to automatically create this content in real time. And here, artist is adding some rocks to make this scene more vivid. So everything is running on real time, and we can add some cloud. The interesting part is actually machine learns to have a more foggy mountain here. It's learns from the data by itself. And you can choose a particular style, a real image, and apply the kind of the style to these particular generate images. So given a single layout, you can generate potentially unlimited number of images if you like. This interface has been used by several major film studios for concept artists. By concept artist, the idea is you can quickly before you are making a movie, right? You can quickly realize your idea without going through the full 3D modeling pipeline. Here, the artist can create a background and add some new objects into it. Our method can be generally used for improved realism of the CG rendering. This is useful for both computer graphics and also for robotics, because oftentimes you want to train a robot on a simulated environment, but you want to make sure your simulation looks realistic. Otherwise, the robot policy will not work for the real world scenario. So here is a game, and we try to make it look like more like cities in German. So here we take a bunch of street view images from German city, try to make this game look more like a real world scenario. Here the input city rendering from the game, and we can then use our method to automatically synthesize all the details which look like a German cities. You can see this kind of like kind of car symbols or not sponsored by any car companies. So in short, I think different visual content creation techniques were powered by underlying software and hardware, right? From the Earth pigment to modern computers and rendering algorithms. So in our group, we are presenting a new idea, which is how we can use machine learning methods to automate it and to learn to create content from millions of billions of images. And this is complementary to other techniques. For example, you can use the strokes to create a draft, and machines can fill in the details. And we have been working on widely used general purpose algorithm. Two of the paper has been cited by more than 7,000 times in the past 5 years. And we are working on for humans. We are working on interactive tools for humans to create content. So that's what we call it, create content for humans. But we're also working on how to create automatic create content for machines. How can we create training data for robotics, computer vision, and self-driving car applications? The idea is the machines can learn from our create environment and it can work better in the real world applications. Yes, thank you for your attention. Happy to chat with you more later.
So I'd like to welcome everybody back. And this is now the time where you get to ask questions of these of our two new faculty members. We have a list of questions we can start out with, but you can also ask questions in the chat in the bottom of the webinar box. And I actually see that we do have one question already, so why don't we start with that? So Zac, the question is, Zac, can we get an update on the SpaceX launch you mentioned, since I assume the video might have been recorded previously and maybe the launch has actually happened?
Yeah, it did happen. So those 3 satellites, they're the mission's called VREX. The satellites are named after the dinosaurs from the land before time. So they're Petrie and Sarah, and what's the third one? I'm forgetting the third one now. So that's they're on orbit. They're running an experiment, a set of experiments to try to demonstrate swarming kind of capabilities for small satellites. So the main experiment on there is a relative navigation experiment where they're talking to each other with radios and measuring the time of flight of the radio signals between the 3 satellites, which can get you a range measurement between the 3 satellites. So just range alone doesn't give you the full relative pose, like relative positions of these guys. So we have some fancy algorithms to do that, to sort of reconstruct the full relative positions and do relative navigation just from those range measurements. So that's the experiment. They launched. When did they launch now? They've been on orbit for a couple of months now, actually. And the short story is they got deployed and we collected a whole bunch of this kind of ranging data right out the gate in the first week. And then we drained the batteries by kind of running them full tilt. And they've been essentially asleep for the last couple of weeks trying to recharge the batteries. So we basically checked all the mission success boxes for NASA and collected all the data we needed to do those navigation experiments. But yeah, we're hoping to do some more fun things with them, assuming they sort of charge up and wake back up soon. So that's kind of where those are at.
Do you have the ability to check the charging, or are you just waiting?
Yeah, we do. So we ping them like once every few days and see how they're doing. But they're kind of in a low power sleep mode right now, where they don't do anything unless we send a signal up to wake them up, basically.
Oh, that's really exciting. Think of those things up there. All right. So please do type in your questions. Oh, we have another question. All right. This looks like it's directed probably at both of you. So why doesn't Jun-Yan take the first crack at it? So educating the undergraduate and master's students is a big responsibility and opportunity. And what are you excited to do in this area?
Yes, so I'm actually designing a new course on kind of image generation open to both undergrad and master students. I think the efforts are twofold. One is more like for CMU students, and the other is for a broad audience. So for the CMU students, we are actually designing some kind of new deep learning homework, which people can get their hands dirty on training these kind of generative models and how to create images, and they can use their own photos to actually test their algorithm. I think we want to get them engaged. So we don't want to give them a pre set of images. We want them to encourage them to try the algorithm, like tweak the algorithm on their own photos or their friends' photos. Maybe you take a phone to capture some photos for your algorithm, and you can have some funny effects. Also, I'm in my course, I also focus how we can help people debug deep learning system. Is what happens if there's bugs. So because I feel like there's a lack of this kind of courses on I think we know how to debug a C++ code if something went wrong, but there are not so much resources how we teach deep learning theory about how deep learning algorithm, how about if you implement something which will go wrong, what should you do? So I try to collect some samples like what could happen, how should we debug, encourage students to share their bugs with us, and I would like to document these bugs, and hopefully in the future, it's easier for the future generation to debug the system. What went wrong? There might be some kind of examples for them. And for the broader audience, I'm also trying to open source the course material and lectures and homeworks to the public, so more people can use it, even they are not CMU students. I used to teach a course on Udacity, which has a very big audience, like 800 students, like for deep learning course. I found actually lots of students want to learn all these kind of techniques, but they may not be able to go to a very like top like university like CMU or Berkeley. So I found it's very useful to open source all the materials and assignments, and as much as possible to the general audience who are interested in this topic. Yeah, that's it.
Great. Zac, do you want to take a stab at that question?
Yeah, sure. So I just started teaching, and it's been interesting doing this all remotely. So I'm teaching a controls course, like an optimal control class, and I think what I'm trying to do with it is take a more computer science viewpoint on control theory, which is typically, sort of the realm of like aerospace and mechanical people. So it's a lot more kind of like algorithmic, and I'm doing everything in Jupyter notebooks and trying to make it fun. So we have like the homework problems are like make a robot quadruped stand on one foot and balance and land a rocket and this kind of stuff. So that's super fun. I'm having a lot of fun with that. And then the other thing that I'm super interested in and have done some things with that I'm going to see how to get this ramped up at CMU now. It's been tough with the pandemic stuff. I love doing hardware projects with undergraduates in particular, and satellite projects in particular. And so the 3 satellites that we have on orbit right now, they were basically built by one grad student in his kitchen over 6 months. But I showed that in the video that the open source avionics stack we have for these small satellites, it's all programmable in Python. And the intention of that was to open it up to undergraduates and make it easy for students to program these things and do experiments on them and actually work on satellite missions. We have another couple of satellites hopefully launching at the end of this year, at the end of 2021 or early 2022. And I'm hoping, fingers crossed, that we can get back on campus and actually get a crew of undergrads involved in that. Right now, we have a couple master's students who are going to, I think, be sort of project leads, but I'm going to try to recruit a whole bunch of undergrads to work on the satellite stuff. And I think that is one of the things I'm super passionate about, just getting more people involved hands-on and that kind of stuff that feels like it's sort of the realm of only, NASA and the government, but showing people, no, you can do this. This is like, it's tangible for undergrads.
That's great. I hope we're back on campus soon so you can make that happen. Or maybe you need to make kits and everybody should be doing it in their kitchen. I don't know. We have a couple of questions, sort of more general questions that were provided by the organizers. And I thought the first one might be interesting to have you answer. So you both work in fascinating areas, but they're also almost completely different. So the question is, what inspired you to get involved in your specific research? One of you want to tackle that first?
I guess I can go. So I've been a space nerd since I was a little kid. I can't tell you when it started, and I don't know that my parents could either. I always loved, anything space, wanted to be an astronaut, the whole deal. And I guess for me, the path towards like being in a computer science, sort of school and a robotics institute is the one that's maybe, a little bit more circuitous, but I've always been, super interested in space things. And then when I first got a chance to work on this stuff, it was actually as an undergraduate. I was a physics major. There was a student project team, a satellite project team at Cornell when I was an undergrad. And it was one of the first, things like this that it's a very rare thing at that point. It's gotten more common. But that was sort of, you know, I jumped at that opportunity and kind of never looked back, and then kept doing this stuff ever since.
Jun-Yan, you want to take a stab at that one? So what inspired you to get involved in your research?
Yes, so for me, I think when I was a child, I often like to, so I looked at lots of movies and cartoons. I also try to create that, but I don't have any resources. The only resource I have is I have a piece of paper. I was supposed to for homework, but I use it for I draw some cartoon or sketches, and I try to draw each frame by frame actually. So but I only have one paper. I erase them. I draw the next kind of bit of action. So I try to help more people create like their stories. Also they may not have lots of resources, they may not have a company working for them, but they can, hopefully they can, one day they can create a short movie, or maybe everyone can design a game just by themselves without knowing all the detail, without have a team, like a big team for them. So that's kind of my initial kind of starting point. And then I jump into graphics, and then I realized maybe to make this everything automatic, we will also need to learn a little bit about machine learning and computer vision. That's why I also started working on machine learning, and I talked to a computer vision faculty. So that's basically, I want to use machine learning and computer vision to help graphics for more people. That's how I started my research program. Yeah.
That's great. I think we'll move to another one of the questions that were provided by the organizer. This is probably one, at least senior faculty hate this question, so we'll see how you as junior faculty appreciate it. So that's, what's one prediction that you have for some period of time down in the future? So 10 to 20 years from now. And I think probably it'd be most interesting to hear about your predictions for the for your subfields, but you can take it any direction that you'd like. And Zach, you want to go back and tackle this one first?
Okay, I gotta think about this. Yeah, it's hard when you don't scope it at all. It's like predict the future, go. So the particular things I'm working on, so there's kind of a couple things that I'm most, they seem like super disparate and unrelated, but the two areas that I'm kind of most really interested in right now, one is legged locomotion, and trying to figure out how to make legged robots do awesome things in unstructured environments, how to like do the mountain goat thing. And for me, that's like a just grand challenge. So in that particular area, you know, I want to, in 10 years, I hope we do have robots that look like those mountain goats that can sort of climb up, you know, rugged trails and this kind of stuff, and without, you know, knowing anything about the environment a priori. And so the space nerd in me wants to, you know, send those to Mars and, you know, have them run around and cover a lot more ground than our current rovers can. And then I guess on the space side of things, the thing there that I've been super passionate about for like the last 10 years that's really been driving me in that domain has been the like lowering barriers to entry and making it cheaper and cheaper to put satellites up. The launch industry has come a long way in the last 10, 15 years, especially with SpaceX. And now there's Rocket Lab and other launch startup that's been really successful at building smaller launch vehicles that are much cheaper. So the cost of launching things have really come down on like a per kilogram basis, but it's still, there's still huge barriers to entry. So kind of in that area, like the open source hardware stuff we do, it's a lot of that's oriented at just getting rid of those barriers for, especially for students in educational institutions, and trying to make it so that the cost of putting one of these things together is like on the order of a few $100 or $1,000, right? Like smartphone kind of prices. So there, I'm hoping that we can sort of get rid of a bunch of those barriers and make it possible so that pretty much anyone who wants to can fly a satellite.
Yeah, it is amazing what's happened with the launch industry. I mean, I'm not in the field, but I don't think I ever would have predicted that would be democratized to the extent that it has been this quickly. So, Jun-Yan, you want to take a crack at that one? Making some wild predictions for the future that we'll hold you accountable for later.
I don't know. I think maybe I guess I can predict what will not happen. Like I think AGI will probably not be achieved in 10 or 20 years. I don't know what could happen. I think for me, I think maybe I will be excited to. I think I would like to see is what maybe in the future, in 10 or 20 years, maybe everyone is watching a different movie or video. So this movie, you can specify the actors you like. So then I have to be the original actors. You can specify the city, the time, maybe the different like other kind of aspects of the movie, or you can play a different game. Everyone is playing a different game with different kind of appearance. So I think it will be customized content in terms of game videos and YouTube videos or movies. So I think that would be very exciting to see, and it can give you some recommendation of what kind of actors would like to see in the movie. So I think everyone is watching a slightly different content, just like kind of the ads recommendation we have now, and a bunch of other kind of book recommendation, like recommending different books for you. Maybe in the future we'll recommend customize different content for you. So that's kind of my kind of prediction, kind of bold prediction. It's very hard to do with current technology, but maybe we'll see how it will look like. Yeah.
Okay. We have a question for you, Jun-Yan. Have you tested some of your generative graphics tools with novice artists, and how have they responded and used the tools?
Yeah, I think that's a really good question. I think artists are actually often more creative with our tools than they are ourselves, and I think I think a couple of like artists from different countries have used our machine learning toolbox for the either for the they are actually for their artwork. They actually sold something like for maybe for $40K, although we don't get anything, but I think it was okay. But also they used it for the art exhibition. One kind of demo my favorite demo is they are the demo which can turn your face into kind of vegetable portraits, and they actually set up this demo on like I think on studio maybe before COVID, and people can come in and then try to show different expression and get their different vegetable portraits. So they actually put that on art exhibition. So I think we are working with them. I think that our goal is not to restrict their use. Our goal is to make the software as easy as possible to use, but they can use it for anything they like. But we try to make it interface. So they just need to provide the software to collection of images, and we can do the transformation for them, and they can tweak which collection they want, and also make the code easy to read and easy to. Actually, a lot of artists know how to write deep learning code. They are very good at that. Actually, if you think about it. And so we try to make it easy to use. We also try to, another thing we are trying to do is we try to make the training faster. We try to make the training maybe used to take a month. Maybe can we make it the training only take a day? Maybe it can only be done by like NVIDIA or DeepMind. Can we make it happen like you can have a single GPU and train for several hours, you can get the same result? So we are trying to make the technology more accessible. Also try to make the testing more fast. Usually you need a high-end GPUs, but can we just use a desktop or laptop? I have my MacBook. Could you run the same model but 10 times, 100 times faster? So we are working on make the technology more accessible. We're also talking to these artists and see what they want and try to make the interface easier for them to use. Yeah, cool.
Okay, the next question is for Zac. Regarding the legged robots, Simon wrote about the environment as being the thing that causes complex interaction, even from a simple system. How are you thinking about incorporating analysis of the environment into your control systems?
Yeah, so that's a big one. So there's a line of work that we've been kind of going down for the last couple of years, which is how to really rigorously handle contact interactions in these kind of control algorithms. And what I mean by that is like for a legged robot, your foot comes off the ground, hits the ground, you have an impact event, and you have friction. All of these effects, not only are they hard to model and non-linear, they're actually non-smooth, right? So an impact event, you're either touching or you're not. So there's this kind of binary combinatorial flavor to those contact interactions. So we've been digging into that problem in a really trying to, from a first principles like physics kind of perspective, to try to figure out how to capture those in ways that are tractable. So if you just care about making a simulator, you can do that, right? But if you care about having a controller that can reason about these things and kind of predict into the future and sort of optimize control inputs with those predictions, it gets a lot harder because you need to then worry about, can you get gradients of these things if it has this binary non-smooth flavor? So that's one area we've done a ton of work, and we're continuing, and we've made some recent progress that hopefully will be out soon. And then a very closely related area that we haven't really dug into yet, but I have a proposal that I just submitted today on this, is trying to figure out how to incorporate perception into this stuff. So, if you're in this, the mountain goat scenario, right? You're on this cliff edge face. You've got it's super rough terrain. You have to figure out where to put your feet and different, friction on different surfaces and all this stuff. How do you actually fuse that in online? And that's a super hard problem. We have some ideas. I don't want to sort of, throw those out yet. They're sort of half baked and we haven't really tried any of them yet, but it's another area. So those are kind of the two big things. One is just how do you reason through contact things and interactions with the environment and the physics of it. And the other is how do you fuse perception into everything.
I once read an article on the mountain goats that said that they very largely used established paths rather than actually covering new ground. So there's probably something in that space too to think about. I mean, it doesn't work for these rovers that are exploring a terrain that we truly don't understand. But maybe once we've explored a little bit more, there'll be some paths that we want to follow and
for sure,
local exploration. Make some of that planning a little easier. Let's see, we have a question for Jun-Yan. What opportunities do you see to collaborate with the School of Art at CMU? And if you want to punt at this one because nobody's been on campus yet, I think that's perfectly reasonable. But my career has been defined by some really wonderful collaborations with the School of Art. So I can assure you that the possibility does exist. But you may not have had a chance to execute on it yet. You have any thoughts for this question?
Yeah, that's a very good question. I think during my second visit to when I'm choosing different school, I was actually talking to Gordon Levin in the School of Art for 1 or 2 hours. He showed me some demos. We are looking forward to working with his students and also other faculties. And so I think there are lots of opportunities. I talked to many artists around the world. They are all big fan of kind of the things that are inspired by Gordon Levin's work, and we as well we're looking to work with him as well as other faculties. I haven't had a chance because due to COVID, it's hard to collaborate. But hopefully there are more opportunities in the future. So one thing I would like to work on is can we build some kind of easy to use software and APIs for artists. Maybe they have a different kind of requirements. So can we have kind of most widely used tools for deep learning tools for artists? Oh, that's one opportunity. The other one is can we teach a course cross-listed between the School of Art and SCS? Maybe we can sort deep learning for art. These kind of give some lectures. So in my current course already, a couple of students are from School of Architecture and Mechanical Engineering. They are interested in applying this kind of technology in their design. So, but maybe we can have a course just for even a more broader audience in the future. And
yeah, I think it would be really interesting to do something of that nature with the IDA program as well, which is one of the unique elements of CMU is this program that brings together people from both sides of campus and in some really interesting courses. So we should definitely, once everything's back someplace approaching normal, we should definitely be able to do that.
Yeah, thanks.
We have a question which applies equally to both of you. So what's your favorite thing about working for CMU so far? You want to start with that, Jun-Yan, since you're already talking?
Yes, I think one thing I like about CMU is there are just so many faculty who are experts on different things. So you can always find, you don't have to send an email to a professor in a different university. You can always find resources if you don't know something and you want to get help from a particular topic. So that's one thing I really like about CMU is you can find a world experts in any kind of area, just within the university, yeah, and ask help, yeah, from them, yeah, and they are all very willing to help, yeah, cool.
And Zac?
So I have a
Favorite
couple. Yeah, so like I would say, having not been on campus, except for twice maybe since I've been here, I found though that there's a super strong sense of community, especially among RI. I found that in spite of everything being remote, there's the community is really strong, and people are really fantastic. So that's been great. And the other thing is, in spite of not having been able to take advantage of it yet, I'm part of the Field Robotics Center, and I've walked through there a couple times, and it's like the ultimate robot playground. It's awesome. So those are two things, I guess, but those are my two favorite things.
Yeah, it's tough. I think back to what my first days on campus were like. It's just so completely different than unfortunately, what the two of you are experiencing. But we are a great community. We do have a lot of experts in a lot of different areas. So we'll get there. All right. Do we have any other questions from the audience? It looks like the queue is currently empty. All right. Anything that either of you would want to share that we didn't have a chance to get to? We made you speculate about the future. We asked you some questions about your research. Anything we didn't cover? Are either of you looking for students? Are you full up already? What's going on in sort of building your labs? Maybe that would be something good to talk about.
Yeah, I brought a couple of students with me who were willing to move from sunny California to Pittsburgh. So that was great, and it actually it didn't take that much convincing actually in a couple of these cases. The other one who I tried to bring ended up taking a job at SpaceX. So what are you gonna do? And then I've recruited a couple of new students this past fall as well. So we're slowly getting into it, and yeah, really looking forward to getting some hardware going.
Yeah. I mean, is there any possibility of building kits and getting them out to undergrads, or something that's great that still works in this?
I mean, I think it is possible. It's the sort of thing where if we had already had the kits debugged, before this all happened, I think it could have been, a doable thing. I think right now I just don't have the bandwidth to do it. So I feel like that's a good summer project. Like we could probably get those kind of kits together this summer when we don't have a launch deadline hanging over us. Last summer we were building these three that flew, and everyone was kind of scrambling to get that ready. But yeah, that's the aspirational goal. If we hadn't been locked down and everything, we might have gotten there. We actually advertised this whole it's called PyCube, our open source avionics stack. And we advertised those last year at the Small Satellite Conference, which is kind of the big conference for this kind of stuff, small satellite stuff, and got huge interest from all kinds of schools and the idea there was that we were actually going to do a fab run and sort of send these out to people in sort of a crowdfunded, and we got over 300 orders logged for the hardware to send out to other schools. So we're still working on that, and there's definitely, the dream is to have a kit and well documented and all this and ship these to people. We just haven't quite gotten there yet. Working on
maybe you need to teach a course as a debugging run for building that kit.
Yeah. So I was doing that last spring actually, and the course got interrupted halfway through because of the lockdown.
Yeah.
The student who's doing the kits and built the 3 CubeSats was the TA for the course, and like we were kind of doing this all as part of a class, and it kind of all fell apart.
Right. Yeah, there were some courses that were easy to take quickly remote, and others that were a whole lot more difficult. That was certainly on the more difficult end of things. Jun-Yan, how's it going in building your lab and your group?
Yeah, I think it's pretty smooth. We have 2 PhD students and 2 master students now. So it's kind of it's at least the size you can have a group meeting or like have some social hours. So we have weekly social hour, weekly group meeting. In the social hour, we play this kind of game called kind of jaw battle. Is the one player is you give a word and one player is trying to join it and the other one is guessing. So we need 4 players. So we already have 4 players. So I think actually more people come to the social hour than the group meeting sometimes. So I think it's plenty of fun, and we are also looking for hire more students this year. So I think last year I actually tried to hire 2 students, and they both got offers from all the places like top 4 schools. We get one, and I lost the other one. But the funny thing is the other student who decided to stay at Stanford, but then somehow he reached out to me again. He's trying to we are collaborating with her advisor at Stanford on some projects. So you never know like how I think kids nowadays try to work with 2 faculty from different universities. They are not only looking for co-advisorship, they're looking at cross-university co-advisorship. Yeah, cool.
Yeah. I mean, it actually points to another question that maybe we could talk about. You know, there are some advantages to the situation that we're currently in. In the graphics lab meetings, we've been inviting students from other universities to come talk. And, you know, that's something we never would have done because you can't fly them around. But now that it's all Zoom, we might as well. Are there any tricks or good things about the lockdown that either of you have found?
I guess in my case, having moved and sort of had, I have a bunch of students who are kind of in limbo, and I'm co-advising several students who are still at Stanford and stuff like this. And it's, you know, and that started, you know, the remote thing started before I moved, and then I moved over the summer. So it actually made it so there was a lot less transitional stuff because we were already doing everything remotely. So in some sense, moving, you know, during the pandemic in terms of my, you know, work life was actually probably easier because everything was remote anyway. So so I run my group meetings now, and half the people are in California, and like, you know, a couple of people in Pittsburgh, and some people are living at home, and it doesn't really matter. So yeah, that's sort of it's been interesting. It's not as nice as having everybody in the same room, but given the circumstances, yeah, it's kind of good, I guess.
Yeah, well, you wouldn't have had everybody in the same room anyway, since
right.
Yeah, you just have the time zones to deal with. Anything occur to you in this space? Any upsides to this situation?
I think there are 2 upsides. One is actually it might be easier to collaborate remotely. So I collaborate with also MIT and Stanford and Berkeley. So all of them, because it's easier to add a collaborator because we are working remotely anyway. Students are maybe in a different city anyway, so it's easier to collaborate. And also, the other good thing for me is I don't need to drive to campus, and I don't need to deal with the snow. So I used to work at MIT. I have to like clear the snow and drive to the campus every day, and yeah, so it's good. We can but I kind of miss the outdoor activities as well. So there are pros and cons, but it's definitely easier for collaboration or for giving talks to other places. It's also quite easy. Yeah.
Well, we could measure this, I guess. We could see if more papers come out with more institutions on them over the next year or so than would have been true in the past. It's interesting. Okay, well, if there are no other questions, and it looks like there aren't, then I would like to thank both of our panelists. I have a lot of respect for your ability to be cheerful and get things going under adverse circumstances. So it'll be nice to see you in person in faculty meetings at some point. But it sounds like things are going really well, and you obviously have incredibly interesting and very strong research programs. So it's good to see that there's a way to make progress on those even in the pandemic. So thank you both very much for coming to this meet and greet meeting, and it was fun to talk to you. And thank you to the audience for your questions.
Likewise, thanks a lot for taking the time.